Well, hello again. This is Adrian Graham, product designer for Bifrost and effects in Maya. And today we're going to look at a bit of a pipeline. We're going to take a fairly high-res sim and we're going to learn how to convert it to Alembic in chunks from the command line. And by chunks, I mean in chunks of frames. And then, instead of having to read all that Alembic data into the scene, have it take up resident memory and everything, we're going to look at the abcImport pipeline so that we could have a low-res representation of our sim, and then it'll get substituted at render time in mentalray. We're doing this is a mentalray workflow, but there are other render time substitution mechanisms in most renderers. In PRMan, it's delayed read archive. In V-Ray, it's the VR proxy, etc. So we've got this scene here. It's it's a pretty sweet sim, just a simple spill of a Bifrost liquid. There's 2.5 million particles, a whole bunch of voxels. It's not that high res. I'm just using this as an example. So your mileage may vary, but I wanted to show some functionality and not have it be too cumbersome to show in this demo. So yeah, so it's just 60 frames. This works for any frame length, obviously, and I've got a preview, a play blast of it here. So nothing much, nothing too fancy is going on here. Just a bunch of particles, a bunch of voxels doing their thing. So if we wanted to mesh this, there's a couple options. Number one, we just turn on meshing, we select the mesh, and we just go to export it. So we could do that. Sorry, we would go cache, Alembic cache, export selected to Alembic, blah, blah, blah. So do we want to do all that? I don't think so. I want to do this from the command line. If my sim has already been cached, then I don't want to have to deal with this interactively. I can run it from the command line and just let it run in the background on another machine, on a render machine, on a render farm machine, or multiple render farm machines, and I'll show you where to look to do all that. So, but just to note, in the Alembic export, you got to make sure, you don't have to make sure, the scripts that I'm going to show you make sure that write color sets is on, because when you write the color set for the Alembic data, you gain access to the velocity and vorticity data that's written out from the simulation, as well as other stuff in the future. We're going to write to Ogawa to save some space, and I believe that's all that we turn on. So let's just turn on meshing just to get an idea of what this is going to look like. Let's hide the particles. Actually, let's hide that guy completely and turn on meshing. These are the defaults. I don't want to waste time showing you any of the settings because that's for a different video. But you could see there's it's pretty compute intensive to generate the mesh, and to have to occupy a Maya for X number of minutes or hours to run a simulation. It's not that efficient. Let's turn off that. Turn on. There we go. So that it looks pretty good. I'm just going to leave it like that. Let me just hide that so we can see what's going on there. So this is my mesh. If I show wireframe, you see it's quite detailed. You get some interesting details there. I'm not going to start playing with the settings. I'm just going to leave it as this, and we're going to go ahead and I'm going to show you next the script necessary to write this out into chunks. Okay, so here I am in my terminal, and I've got a couple scripts to look at, batch abcexport.mel and .py. So if I look at the .mel, very simple, and I'll give this to you guys. Look in the blog post for a link to this. It's just a couple lines. We're running a couple lines of Python, and we're going to run this script called batch abcexport. We're going to import a Python script. We're going to run it, provide a start, an end, an out path, etc. And what that's calling is a Python file, which you don't need to understand this. I'm just showing you guys. We do a couple things. We generate chunks, which basically takes start and the end and what the chunk size is. And by chunks, I mean chunks of X number of frames. So in our case, we're going to do chunks of 10 frames. It's a 60-frame sequence. We're going to write this out in chunks of 10. So frames 1 to 10 will be chunk 1, frame 11 to 20, frame 2, frame 21 to 30, frame chunk 3, etc. So that means that we don't have to write out one huge, massive Alembic file, which I know we've all had to deal with, which is not a fun thing to have to manage all that data, dealing with these files that are 8, 9, 10, 12 gigs in size or more, possibly hundreds of gigs in size, which I've run into, caused me to rethink this and to write this tool. So so we generate the chunks, and this just spits out a number of which frames to go in which chunk. And then, and the limitation here is that you have to select the output mesh, and I'll show you how to do that in the script. And then it generates a list, it takes the output path, blah, 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 it writes to the chunks, and here's the meat of it. These are the Alembic job arguments. So here's the frame range we specify, the beginning of the chunk, the end of the chunk, write UVs, write color sets, data format Ogawa, the name of the node, and what file to write it out as. So let's go back to the .mel, and what we're going to do is we're going to modify this script. So here, my Bifrost mesh, first of all, you need to select it. You can also select multiples in here. Let me just recenter this. So it's called Bifrost Liquid 2 Mesh. So that, run that Python. So start, in this case, it's going to be 1. End is going to be 60. My output path, I'm just going to put in, and you put in the name of a directory, not file name. So C temp Bifrost, we'll call this Alembic export demo. Okay, so that's that. So now we could do this in a couple different ways. We can just run that script from within Maya. We could just source that script, or you could run it from the command line in batch. And so what we need to do is set our Maya project, and that's right here. The directory that I'm in. So I'm going to do in bash, I got to do export. Obviously your shell will necessitate a different environment variable, and if you're doing this on Windows I am on Windows, but this is using the console too, using the command prompt, you're going to have to set that in the environment. Speak to your friendly neighborhood pipeline TD for more information. Export Maya project equals, and I'm going to use this, I think, I'm not going to use the sig drive path. Cygwin users, don't use the sig drive path because Maya doesn't like it for some reason. So do that. Put that in quotes. So grep Maya project, there we go. And scenes, the file is right here. It's this mesh port cached. You know, one thing I forgot to mention is that you have to put those scripts in your home Maya scripts directory. So depending on which platform you're on and what your setup is, that might be in a different place. On Windows, it's in documents, but here I've modified my environment to go right into my home directory, Maya scripts. I think that's might be a link, but anyways, so we've got our we've got our mel script, and all it does is run those, sets up those variables, and calls the Python script. So we go into our project and look at our file. It's this guy. That's the last one here. And we're just going to run a batch command. So we've got our command line here, and you have to use the -file flag and then the relative path to the file. So it's going to launch one of these guys, a command prompt window, but it's not going to run anything in there. What you have to do, and this is off the screen right now, but I'll move it on the screen, it's an output window that will get generated when you launch that. So it shows all the startup stuff, open the file, right into chunk 1, and let's move that off to the side and just minimize that. So I'm running screen right here, so I can go to this, my destination is Alembic export demo. Oops. There we go. So it puts it in a subdirectory named after the geometry that you're exporting. If you have multiple geometries, I believe it'll do them separately. But if I keep listing this, you'll see it's growing in size, 134 megs. And also, if you watch that output window, you'll see these are the subframes that it's writing to the chunks. So I'm going to pause this and write a few chunks and give you an idea of, or I'm going to pause this and write all the chunks, and we'll come back when it's done. So here we're almost done writing out the chunks. And you can see, I wanted to show you this before the output window went away. When the process is done, this will disappear. But so we've got the frame spitting out, and with every break in the chunk, we get a little update message. And we've just got one more frame to go. And we could see that we are almost done writing chunk 6. And what's the total? It's not that bad. It's 9.1 gigs, but I've written out some sets of Alembic data that are 150 to 200 gigs, and that would be an awful thing to have to handle a single file of that size and have to move it around, back it up, archive it, deal with it. So that is, this is where we're gonna, this workflow really sings. Okay, so here we are back in Maya 2016. I've got these 6 cubes, and each cube is animated. Its visibility is animated such that it follows the frames of the chunks that it contains. So chunk 1 is visible from frame 1 to 10, and then on frame 11 it hides itself, and chunk 2 is visible to frame 20, 21 it hides, etc., etc. So you could see I've just animated these, just keyframe their visibility in step tangents. So let's start with chunk 1. And what we're going to do is, and make sure you're not on the shape, but you're on the transform of the cube. Go under the mentalray section here, geometry shader, and this is mentalray specific. So obviously another renderer is going to have a different workflow, but this is for, I'm talking about mentalray right now. Turn on under geometry shader, enable geometry shader, and map it. And we're going to type abcImport. Okay, so now if we look at the node editor, and we look at up and downstream nodes, we will see a bunch of stuff that we don't need to see, but we will see that the message goes to the MIGO shader. That's going to help it talk to the Alembic file. So let's take our path, and I have a little alias to. Okay, so there's my full path. I'm going to copy that. I think the SIG drive isn't used properly. Oops, wrong. So let me open Maya, and I'm going to paste that in, and I'm going to give it just a plain old Windows path. C:. And this is important. Time by default is not connected to anything, so you can just type an expression equals time. There we go. And that's it. You don't have to change anything else. There are a couple more things that you do need to do. And you'll recall last time, earlier in the video, I was talking about the writing out the color sets. Well, we need to generate those sets manually. So we're going to go into modeling mode, into mesh display, color set editor. And before I do that, I want to create the hypershade. I'm going to create, let me make this right size here. I'm going to create Bifrost liquid material. All right. And I'm going to assign that to all my cubes. Now, if you go to the attribute editor, now you'll see there's my liquid material, but there's no channels. It's not able to read any channels right here. And that's because we haven't created the color sets. So let's create the color sets just on one, and mesh display, color set editor. And we're going to create a new color set and just use the defaults here. And we're going to call this Bifrost velocity. So we create the velocity, and the same thing, and call this Bifrost vorticity. Okay, and you'll see now in the material for the chunk, now you'll see the two channels there. And as a matter of fact, if you could add any arbitrary color set. So I could even call this Bifrost whatever, and reselect him. And now we've got this, the channel here. So this allows us to remap the color, remap the the reflection, the Fresnel, blah, blah, blah. So you've got all your standard channels available to you. Well, not all of them. You've got velocity and vorticity, but this is what was exported. Note that every single one has to have the same channels, otherwise they won't show up. So, or they won't show up in the shader. So if I assign these guys, assign existing material that, and I go there, I think it doesn't show up at all. Yeah, see, they need to have the exact same list of color sets in order for this to resolve. So I'm going to add that to all of them and come back when I'm done. Okay, so they all have color sets. And if we assigned it, so let's go and focus on the material. There they are. So color map channel. So let's just use, let's say the diffuse will remap with the velocity, and we'll just, I don't know, just do a lower velocity or something, and we'll do color that's easy to spot. Oh, well, that's not that easy to spot. So let's go green to blue. Okay, and set the transparency to 0 just to get an idea. And let's go and render this. So just to show you that stuff is actually happening, let's open the render view, bring render here. I don't know, just use the perspective camera and set our render to mentalray. Well, I guess with the default shader, or default lighting. Oh, well, there's our the cube at the beginning, and then let's zoom forward to, I don't know, frame 26. But you know what we didn't do is we didn't create an ABC import for each of these. So let me go do that, and I'll continue in a sec. Okay, so you see I've selected all my ABC imports in the outliner, and if I step through them, you'll see I've brought in the path properly. There's no attribute editor template for this, so you can't browse for a file. We need to sort of fix that. But yeah, they all need to take in the time expression, no big deal. Okay, so now on frame 26, if we bring back our render view, hit render, we should see something. There you go. So obviously I need to bring in the camera that I had for that render before, but let's do this. Let's focus on, let's just scroll over there, material, go back, and diffuse, we're going to do something like this, just make it a little darker, and then this guy's going to be lighter. We'll base it on the vorticity maybe, and not velocity but vorticity, and then the transparency set back to like 0.95, and here's a decent setup. We'll go back to go into go into the render globals. This is what I like to do. Go into scene, create an IBL, make sure emit light is turned on, browse for an HDR. I've just got a bunch of HDRs here. Why don't I just use, I don't know, one of these, and just some random one. It's funny, the IBL sphere is so small. I think that's a bug. We can just hide that, and we can also say don't render it. And let's render it. So here's the render. Obviously, this workflow is great for single nodes that don't require component level assignments. The entire node stack needs to be assigned the same shader. But it's awesome because we've got a scene that has practically nothing in it, this tiny little overhead scene with just these cubes in it, and we can get it to render all that data. So let's bring this render workflow setup into our animated scene that doesn't have any Bifrost data and render that. All right, so here we've excuse me, referenced in the geometry from the animation geometry. I've just deactivated this the Bifrost liquid, but yeah, we can see the animation there. And there's our little cubes in there, our reference cubes, and if we render, and there you have it. Of course, my render settings aren't perfect. As a matter of fact, they're all defaults, but you get the idea. So here we've got a scene that hardly has anything in it, just animation and some reference nodes or some abcImport nodes, and it all just works. So that's the pipeline, and I know that you'll have questions. Please post them on this thread, and I'll try to answer them as quickly as I can. So thank you for listening to this quite long and detailed blog posting. We'll talk to you guys soon.